Greetings, chemistry students. Today we're going to start our unit on solutions, molarity, acids, and bases. We're going to focus today just on the first two parts of this, solutions and molarity. So first of all, a solution is a homogeneous mixture containing a solute dissolved in a solvent. Homogeneous means it is uniform throughout. You can't see the individual particles that make up a solution. And the solute is what you're dissolving, and the solvent is what it's dissolved in. So for instance, if you're making a solution of sugar and water, your sugar is the solute, the water is the solvent. And when you've made the solution, you can't see the individual particles of sugar in the water. It all looks uniform. Unlike, for instance, something like Italian salad dressing or oil and vinegar salad dressing, where the parts separate out and you can see the different parts. Now, solubility, how much you can dissolve, is affected by two things: temperature. For instance, with sugar and water, the hotter the water, the more sugar you can dissolve, and pressure for gases. So you can dissolve a gas into water, for instance. That's what a soda or a carbonated beverage is. And the higher the pressure, the more gas you can dissolve. That's why it's important to keep the cap screwed tightly on a bottle of soda when you're not drinking from it. It will keep the carbonation dissolved. We're going to look at something called a solubility curve. I'm going to show you this real quick. It's pretty simple to understand, but it's a graph of solubility versus temperature, and you can be unsaturated if you don't have as much stuff dissolved as possible. You can be saturated if you have the maximum amount dissolved, or you can actually be what's called supersaturated, and I'll explain how that happens by showing you a graph, and it's made by changing the temperature here. So if we look at this, why is this not? Right. So if we look at this graph right here, you can see that we have something like NH3. As you increase the temperature, its solubility, how many grams can be dissolved in 100 grams of water, decreases as it gets hotter. That's because NH3 ammonia is a gas, and gases become less soluble as temperature goes up. That's also why, for instance, you have to carefully regulate temperature in an aquarium, because as the temperature goes up, there's less oxygen dissolved in the water, which can cause your fish to die, for instance. If we look at something like potassium nitrate here, its curve increases pretty steeply. The hotter the water, the more you can dissolve. So let's say that we are at 50 degrees Celsius. If you have 60 grams of potassium nitrate dissolved in 100 grams of water, then your solution is unsaturated because you are below the line. If you have 80 grams dissolved, you are saturated. And if you had 110 grams, what is this doing? Dissolved, then it is supersaturated. And the way you can get 110 grams dissolved is by increasing the temperature to, say, 65 degrees, where you can dissolve 110 grams. And then you cool it down, and it can actually stay dissolved, even though at this lower temperature, the maximum solubility is only 80 grams. But you can actually do this. For instance, if you make sweet tea, you heat up the water, you dissolve the sugar, then you cool everything down in the refrigerator, you have a supersaturated solution. So that's just some terminology there. Now, the next thing we're going to talk about is concentration, which is actually measuring the ratio of solute to solvent. And the way we're going to measure that is through something called molarity, which is abbreviated with a capitalized italicized M, or you can just write a capital M and underline it. Molarity is moles of solute per liter of solution. So, as you might guess, we're back to moles, and this is moles per liter. And if you look on page 3 of your reference tables, you'll find the formula for molarity is right there. Now keep in mind this is liters. Liters, 1,000 milliliters. So if you wanted to make a 1 molar solution, you weigh out 1 mole of your solute. You would need to convert some moles into grams to figure that out. And you would add water until you have a total volume of 1 liter. So we're going to look at this problem. If 40 grams of glucose are in 1.5 liters of solution, what is the molarity? So if we have 40 grams of glucose and we're in 1.5 liters of solution, we're trying to find molarity. Well, molarity equals moles over liters. So molarity, well, we know our liters are 1.5 liters. The one thing we got to do is figure out how to get these 40 grams into moles. So we're going to say 40 grams of C6H12O6. We're going to convert those grams into moles. And we're going to say, well, carbon has a mass of 12.01, and we got 6 of those, plus hydrogens, 1.008. We've got 12 hydrogens, plus oxygen has a mass of 16. We've got 6. So this has a mass of 180.156 grams. So we do some real simple math and find that our moles is 0.222 moles. We're then going to take that, plug it in, 0.222 moles, and some pretty simple calculations gives us a molarity of 0.148 molar. So that's how you would do a molarity problem. I'm going to show you one more molarity problem. So this problem asks how many grams of calcium chloride are needed to make 6 liters of a 0.85 molar solution. And we know that molarity equals moles over liters. So we have our molarity is 0.85 equals moles, we don't know, and liters is 6. So we're solving for x. So to do that, we're going to multiply our 0.85 times our 6, and we have 5.1 moles of calcium chloride, which is not quite what the problem is asking us for. It's wanting to know how many grams that is. So we're going to need to convert our moles into grams. And yes, it all comes back to moles. So we know that 1 mole of calcium chloride equals the mass of calcium plus the mass of chlorine times 2. So this comes out to be 110.98 grams as a mole. We're using the numbers off the periodic table. Calcium is 40.08 and chlorine is 35.45. So we multiply this out and we get that we need 566 grams of calcium chloride. So to make this solution, you would take 566 grams of calcium chloride and then you would add water until your total volume equals 6 liters, which is how much our volume was. So that's how we do some molarity problems. So I'm going to give you a couple of them to try on your own.